Hi guys! In this video, I'm going to talk about paired samples t-test.
Before I give you the concepts of paired samples t-test, let me first show you these two questions. First, do you believe that 2 months of observing an intermittent fasting diet can decrease your weight? Second, do you believe that daily practice for a month can help you improve your math solving skills? You do not need to answer these questions, but if you like to, please comment them below. Now, how can we answer these questions? Let us first examine them. In the first question, we are concerned with the variable weight. And in the second question, we are concerned with the variable math solving skills, which might be measured by students' scores in an examination. These two variables are continuous. They are measurable and can take decimal values. Another observation. These two questions state time periods. That is, in the first question, a given period of 2 months, and in the second question, a period of 1 month. So these two questions are concerned if factors like intermittent fasting diet and daily practice of solving mathematical problems can significantly affect the changes or improvements of a continuous variable given a specific period of time. And these types of questions can be answered by the paired samples t-test. So what is paired samples t-test? The paired samples t-test compares two means that are from the same individual, object, or related units. The two groups typically represent two different times. Example, pre-test and post-test. It aims to determine whether or not the mean difference between paired observations is significantly different from zero. So in paired samples t-test, we are comparing a continuous variable from a single population or a group of the same participants, which is measured before and after giving any treatments or interventions at a given period of time. That is, we are seeking for a sound evidence that the intervention we have is either effective or not effective. Examples: test scores of learners after introducing a new method of teaching, pre-test and post-test. Another one, weight after doing home workout for 2 months, before and after. In the first example, the intervention is the new method of teaching, and we compare the pre-test scores and the post-test scores of the learners. In the second example, the intervention is doing home workout, and we are comparing the weight of a group of individuals before and after 2 months of doing home workout. Now, what are the assumptions of the paired samples t-test? First assumption, random sample data from population. Second, the two groups should be dependent or paired. Number 3, your dependent variables should be continuous. Number 4, there should be no significant outliers in either of the two groups. Number 5, the difference of the observations, that is post-test minus pre-test, of the paired groups should be normally distributed. So in the fifth assumption, we first need to subtract the values of the dependent variables before and after giving a certain intervention. To check for outliers, we have two methods. It can either be numerical or visual. First, the IQR method. This is a numerical method. We first need to solve for the IQR, for the interquartile range, which is equal to third quartile minus first quartile. Then construct the lower bound and upper bound, where lower bound is equal to the first quartile minus 1.5 times the IQR. And then the upper bound is equal to third quartile plus 1.5 times the IQR. Any data point less than the lower bound or more than the upper bound is considered as an outlier. Second method, we can check for outliers visually by plotting the box plot, which can be plotted using the calculations of the IQR method. So here's an example of a box plot. In this box plot, we can see the median value. We can also see the first and the third quartile. We also have here the IQR or the interquartile range. And the maximum and the minimum values plotted with outliers excluded. These minimum and maximum values refer to the lower bound and upper bound introduced in the IQR method. And outliers are shown if requested in the software. These are points outside the minimum and the maximum values. Now, if outliers exist, you can just delete them. To check for normality, we have three methods. First, by using the distribution plots or the histogram. This is a visual or graphical method. These are examples of histogram. A variable is approximately normally distributed if the histogram is in the form of a bell shape. So between these 2 points, the first one is approximately normally distributed and the other one is skewed to the right. Second method is by using the QQ plots. This is another graphical method. And these are examples of the QQ plots. If the data is normally distributed, all the points will be close to the diagonal reference line. If the points sag above or below the line, there is a problem with the kurtosis. And if the points snake around the line, then the problem is with the skewness. So if there are problems with kurtosis or skewness, your data is not normally distributed. In these plots, the first one is approximately normal. The third method is a statistical method, and that is by using the Shapiro-Wilk test. Here are the hypotheses of the Shapiro-Wilk test. The null hypothesis, the data comes from a normal distribution, while the alternative hypothesis is the data deviates from a normal distribution. For the decision rule, if the p-value of the Shapiro-Wilk test is less than or equal to alpha or the level of significance, we can reject the null hypothesis, implying that the data deviates from a normal distribution. And if the p-value is greater than alpha, we fail to reject the null hypothesis, implying that the data comes from a normal distribution. So your variable is normally distributed if the p-value of the Shapiro-Wilk test is greater than the level of significance or alpha. If the data is not normal, you can resort to Wilcoxon signed rank test. Now, what are the assumptions and rejection rule of the paired samples t-test? For the hypothesis, we have here the null. The difference between group 1 and group 2 is equal to 0. And the alternative hypothesis, the difference between group 1 and group 2 is not equal to 0. And for the rejection rule, we can reject the null hypothesis when the significant value or the p-value is less than the level of significance or alpha. So one can say that a certain intervention or treatment is effective if the p-value of the paired samples t-test is less than the alpha. Here are my references.